Young people, welcome back. BNB in the house, y'all. Excited about a brand new chapter, chapter 11. And yes, this first lesson in chapter 11 is quite the doozy. Yeah, I said doozy. It's something that's going to be easy to describe, but at the end of the day, that concept of inverse is something you're just going to gain over the course of a couple of classes, years, or whatnot. But let's take a look at what we got, guys. We've got chapter 11, lesson 1, inverse variation. The first objective that they have is identify and use inverse variation. So identify and use inverse variation. Second is to graph inverse variation. So inverse variation. Yeah. You're going to hear people say inverse is the opposite. You're going to say inverse variation is a combination of direct versus indirect. And as we get into this, guys, we've dealt with linear, we've dealt with quadratic, we've dealt with all types of stuff. So nothing too challenging, but definitely the concept, I would say, is still in the functions, linear, or you can just say inverse. Inverse itself can be considered a concept because it can span across different areas. And of course, the skill, as you heard in the objective, is identify and graph. So swap back. Students will be able to identify and graph inverse variation. Got it? Let's get it. And guys, I think we got a full one today. And what I mean by full one is, we're not doing any hour-long videos anymore, but we do got a nice one. So good, full handout, guys. I see graphs, I see tables, and we're getting right into it with our first table. Determine whether each table or equation represents an inverse or direct variation. Explain. So we're going to explain while doing here. So for number one, I got a table. And for me to know whether or not it is an inverse, I have to multiply the x and y and see what the value is. So for the first coordinate, half and 8, I get 4. 1 times 4, 4. 2 times 2, 4. Do you notice that no matter what the x and y is, I get the same value, 4. That's what we're looking for, guys. So there it is. I'm boxing and explaining through the multiplication there that yes, it is. Now number 2 is straightforward. It literally says x times y equals 2/3. So that is a direct variation of x and y. Doesn't matter what x is, doesn't matter what y is. When you multiply those two, you're going to get 2/3. We showed that in number 1. X changed and y changed over and over and over. But when you multiply those two, you got that. So before we move on, I'm going to give it a quick little pause, and I'm going to explain that one more time. Wait, not yet. Right now. So, and the reason why I say right now, guys, is in this pause, you'll see that 1 and 2 is inverse. Number 3, though, is a direct, and it's going to say variation once we get it moving again, because it says y equals. Now, the original problem doesn't say y equals. We have negative 2x plus y, but I maneuvered it. I rewrote it. I expressed it as a linear function, linear equation, and solved for y. So now y is a direct variation of x. I need to know what x is to tell you what y is, right? Well, in the first two, no. Didn't matter what x and y was, it was a inverse variation, meaning when you multiply those two values, those x and y values, you're guaranteed to get the same value. Doesn't matter what your x and y is. So that's the explanation in the top half here, and you're going to see some in the middle and bottom sections, but I want to take a second to explain the y equals mx plus b. Yes, linear, right? That's number 3, whereas 1 and 2, not so much, right? Let's get it moving. Could have paused after I wrote direct variation, but I paused it then. So let's get that out of there. And then we get the rest of that out of there too. Oh no, it's gonna be right on top. I'll take that. Oh, a little big though. Assume that y varies inversely as x, okay? Write an inverse variation equation that relates x and y, then graph the equation. All right, so to write the equation, well, you know what y equals, and you know what x equals. Well, what we're gonna do, guys, is we're gonna understand what inverse variation does for me. What it's doing for me is knowing that x is 5, y is 2. What's 5 times 2? You got it, 10. So if it is, how do we say this? An inverse variation, doesn't matter, it's always gonna give me 10. So 5 times 2 is 10. What else will give me 10? Well, let me plot it. Can I plot it? We got 5, 2. And recognize that that coordinate plane isn't doing 1, 2, 3, 4, 5. It's going 2, 4, 6, 8. Being aware of your coordinate plane. So got 5, 2 plotted. But recognizing that with the 5, 2, what else will give me 10 when multiplying the two values? Well, of course, 2 and 5. So I literally just swap those two, and by swapping them, I've got another point. So inverse variation, right? Just you swap them, that's the easiest way to go. So 2, 5 is on there, but I want to keep going because x, y has to equal 10. That is what we're working on, right? So 1 times 10 equals 10. Keep going. I'm just getting values that I know will work for this actual equation, right? -2, -5. And keep it going. Half times what? 20. There we go. So many choices here, because when you graph it, you're gonna recognize I'm gonna have arrows that can go on forever, saying that this graph doesn't just stop or cut off. Just getting more examples, guys, hoping that you're understanding. Got a few that are positive, got a few that are negative, but they all equal 10. So those are all valid points for this graph when I want to graph the equation. And what equation am I graphing? Right there at the top, guys. X, y equals 10. Yes, that is the equation. It can be your equation. So getting the points now, this is what's gonna be cool, guys, as I am plotting just the list that I made. Plotted 110, you know. Now, here's my attempt of doing a beautiful graph. I've got some curves, you know, it's not just straight, it's going to do the curve, right? And here's the bottom, or the inverse of it, right? And now you're going to notice that it's going to curve. And that's what I meant by the arrows on the end, guys. So I created my own points using the equation that I was able to, you know, come up with. You can see I'm noticing I'm adding a few more just so my clarity on the, what is that? Bottom portion of the graph, third quadrant. And boom, got it. So for the next one, guys, we're gonna use the same process. We've got an x and a y value. The x value is -6, the y value is -6. So -6 times -6 is 36. I'm looking for other values, such as 2 times 18, such as 4 times 9. Now those are all positive, right? But what about the negatives? Well, let's get one more. 3 times 12. Good. What about the negatives? I want some negatives. Or maybe I want to graph those right now. Because as my mind starts to understand what's happening, I start to realize, okay, is this one going to look similar to number 4? Or is this one going to be completely different when it's graphed than number 4? All right. So getting it in. 2, 18. Again, recognize that coordinate plane is now going 4, 8, 12, 16. So be aware of your coordinate planes. I got my 2, 18. My 4, 9, is that it? No. 2, 18. What's that? I just did the flop. There we go. And connect them. So it does look similar to number 4, recognizing that it's going to keep going on forever and ever. So those were 4 points. Now I just want to do the same 4, except this time swap them, right? And of course, no need to swap -6, -6. It's already in there. But keep going. -2, -18, right there at the bottom of that grid. Of course, the next one, get that 4 in there. Negative, of course. And get the next one, and you can kind of see. So, didn't list all of the negative values, but did, well, let's go ahead and list them, right? I think it's worth listing them. Because when you list them, it kind of helps the eyes in seeing them on the grid. And again, just inverse variation. How I help the kids in class when I know they're getting a little confused. I just go, oh yeah, just flip them. Yeah, just flip them. Flip your X and Y, you'll be fine. All right. But in this sense, guys, not only are you flipping your X and Y, but you're also coming up with other values that make that equation true. All right. And that's how we can graph it now. It's because we've got multiple points that work for that equation. So in this sense, in number 6, y is -4, x is -12. So let's go ahead and check. What is x times y in this situation? Positive 48. So literally, and I don't know if I did it in the last one, but should be doing it here. xy equals 48, right? So how many other values can I come up with for x and for y that will multiply will give me 48? That's the process. And 8 times 6 is 48. What else is 48? 4 times 12 is 48. What else is 48? 3 times 16? I think it's 48. No, they're gonna use that value. Yes, look at that. That's what I'm talking about. All right. So again, there's 1, 2, 3, 4 points. And again, check your grid. It's 0, 4, 8, 12, 16. So -12, -4. See, I gave my little check this time, kind of. It's what I do. Should have did it in the other ones to help you out, but you know, I'm human. +8, 6. So again, just making sure on your grid you're finding those points correctly. All right. And then of course the last one that I'm going to have over here, 316. Now notice again, I've got 1 in quadrant 3. There's 1 coordinate. Quadrant 1 has 3 coordinates. So this is where my brain goes, oh yeah, it's going to give me that little curve, just like the other 2, right? And there's the curve that I'm looking for. Right? Added the +16.3 to get that bottom of the curve, right? As my eyes saw what was going, I was like, oh yeah, 16 times 3, there's 48 again. But now, of course, let's get more values in the 3rd quadrant, where x is negative, right? Not only is x negative, but your y is also negative. So, -8, -6, where's that at? Boom. And come on down, boom, right? All right, good. Next one. Ooh, there's that check again. Check, graphed it. -4, -12. And boom, right there, and boom, right there. And kind of, guys, that could be enough for me, but since I already know -3 and -16 will work, I'll use that as well. So this is even gonna go further downward, but closer to that y-axis, right? So good enough, understanding, and inverse variation. And again, guys, lovely time to use Desmos. Use or even a graphing calculator where you would plug this in, xy equals 48, which again is not there. Make sure you do it right. And just make sure that your graph that you're doing with your pencil on the paper is very similar to what you see on your screen. So here we go, last one that we are graphing. Number 7, y is equal to 15 and y is equal to 3. So it looks like 3 times 15 is 45. What other 2 values when multiplied will give me 45? Here we go. 5 times 9. And -3, we're already getting into the negatives. You couldn't think of any other positives that would work? Well, of course I can, but hey, KISS method. Keep it simple, smarty. All right, so let's go for what we know. I've got 1, 2, 3, 4, 5 points. Here comes 6 points. And if 6 points is not enough, then maybe I'll come back and get a few more. Or how about 7? 7 should be enough, right? Well, we're about to find out. So here we go. On the coordinate plane, we'll start plotting some of these actual coordinates. The first one they gave us is the first one we'll plot. So we're plotting x is 3, y is 15. And again, recognize this is going by 5s, right? And I'm trying to get more values, and this is the technique we're going to use. There's my formula. There's my equation. xy equals 45. So if y is 10, then x has to be 4.5. Solving for y, right? Now, I've got a point. I've got the point of x is 10, y is 4.5. Now, I can keep doing that. Just do it over and over and over, just keep getting points. And that's what's cool about it, is knowing that when it is inverse variation, you have the equation, you can figure out x and y, just plug in the value for x, solve for y. Plug in the value for y, solve for x, all right? So let's do it again. This time, xy is equal to 45. And now, instead of plugging in a value for x, we can plug in a value for y. And let's plug in the value of 10 again. And of course, since we already know, x must be 4.5. Good. And again, what do we just do, guys? We swap them. So showing you the algebraic way of how to solve, but knowing that all I have to do is solve it once and then flop it. Oh, my editor does make fun of that sound when he does his thing, flop it. But we got it, guys. Let's get those points graphed on that coordinate plane. Again, recognizing the coordinate plane is not going 1, 2, 3, 4, 5. This one is going 5, 10, 15, 20. So there we go, 3, 15, got it. 5, 9, just inside of the 10, right? Next, -3, -15. So I'm in the third quadrant, of course. And I'm just moving along, -5, -9. So go back, go down, and there we go. And again, really close to that 10, but not on the 10, right? That's where you're not gonna be perfect in your graphing, but you're gonna be correct, all right? It's real easy to see a kid that knows what he's doing, a kid that's trying to put something on a coordinate plane that has no idea what they're doing. Your teacher's gonna see this and know, oh, okay, looking good, all right? So smooth lines, arrows on the end, because again, it will continue on and on and on. And that's what we're looking at, that's what we got, guys. So as I spin around and give you a little bit more of my attention, first part, second part, we're getting into the third part. And the third part, guys, how can I put this? Repetition, 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 repetition. So we've got 6 of them here. We've already gone about 15 minutes into the video. I hope it is exactly what you were hoping for, and not answers, but explanations. All right, so let's see if we can explain the bottom half of this and get you guys prepared for class. Assume that y varies inversely as x. Okay. Write an inverse variation equation that relates x and y, then solve. Ah, okay. You mean what we were just doing? So, again, 8 times 4 is 32. So if y is equal to 4 and x is equal to 8, then 8 times 4 is equal to 32. Yeah, got it. That's not an equation. Let's write an equation. X times y is equal to 32. Now, find y when x is equal to 2. Okay, so if x is equal to 2, I'm going to plug in 2 for that x. I got 2y is equal to 32. I'm going to solve for y by dividing both sides by 2, and there I have y is equal to 16. So assume that y varies inversely as x. Write an inverse variation equation that relates x and y, then solve. Bam, solved. Got it. So repetition, repetition, repetition. Let's do it again, right? And what are we waiting on? So number 8 is done. Let's see if we go odds or evens here. Oh, I'm boxing my answers here, I suppose. There we go. Beautiful box. Ready to go. Let's knock it out. And here we go, guys. Looking at number 9 or number 10. Looks like that was 8, and here comes 10. If y is equal to -6, when x is equal to -2. You hear me say when x is equal to -2, right? Because if x is positive 2, y would be something else possibly. Not possibly, would be. We're gonna get a x times y is equal to 12 because negative 6 times negative 2 is positive 12, and therefore inverse variation. We got it. Now again, there's your equation. Let's go ahead and solve for what they're asking for. Find y when x is 4. We plugged in 4 for x. What times 4 gives me 12? 3. Y equals 3. So we found y. Number 12, if y is equal to 15 and x is equal to 1, then my equation would simply be xy equals 15. And now, again, repetition. They're going to ask you to find y when x is, or they could flop that and say find x when y is, right? But understanding what we're doing here, when y is negative 3, yeah, negative 3. They did switch it up on us, guys. Glad I'm paying attention. So when y was negative 3, x was equal to negative 15. So again, understanding your concept of what is happening. I have an x and a y. Those two values are getting multiplied. Once I have that, now I can use that information to go back and get other points, other values for x and y that make this equation true. So for number 9, as we are probably going to knock out this entire handout, we don't do that too often nowadays. Xy is equal to, what's that, 21? Negative 21. You notice here in number 9, I didn't label my x, I didn't label my y, because I know what I'm doing. Looks good. Teacher always likes it. But again, repetition. Now I'm at the point where I can just write xy equals negative 21. When x is negative 3, y is equal to 7. Boom, bang, pow. So number 10, you mean 11. Number 11, if y is equal to 24, when x is equal to negative 3. Hear that? When, right? When x is equal to negative 3. I'm labeling up here. So x is negative 3. Y is 24. Let's go ahead and write an equation that will work for the inverse variation. XY equals 3 days, 72 hours. So if I know XY is equal to 72, then I can tell you what X is if you tell me what Y is. Or in this situation here, I can tell you what X is when Y is negative 6. So divide both sides by negative 6, and of course, x is going to give me negative 12. So there's my equation, and there's the solving when they are asking for a specific value of my variable. All right. Well, guys, it looks like I got one left, and we are getting to that 20-minute mark of just talking about the handout and whatnot. I know you've been watching longer than 20 minutes, but I appreciate your time. So, wrapping it up, last one, 13. If y is equal to 48 and x is equal to negative 4, then I am literally going to say negative 4 times 48, and that's me using a calculator right now. Negative 192. So, there's the equation, right? An inverse variation equation that relates x and y, then solve. So, what do you want me to solve for? Find y when x is equal to 6. Find y. So I'm plugging in for x to find y. Same things we were doing back when we were solving for b and y equals mx plus b. Same thing we were doing when we were solving for x when we had systems of equations. So guys, nothing new in the sense of the skill of solving. What's new is understanding what they're talking about with this inverse variation, direct variation and whatnot. So all of that talking, and I didn't finish talking about 13, but it's there for you, right? Divide 6 into the negative 192 and you get a negative 32. Y is negative 32 when x is 6. Once again, guys, like I said, brand new chapter, chapter 11, lesson 1. There's a lot of good information in this chapter. I look forward to seeing you guys in the next videos. Peace, love, and soul.